Good morning, students. I am Shilpi Yadav. Welcome you all in your online science class. I hope you all are well and safe at home and you all started the learning work also. Today we are continue with our revision of chapter 1, that is matter in our surrounding. So students, you already know that matter is having a 3 states: solid, liquid and gas. And you also know that solid, liquid and gas, these 3 states are also interconvertible to each other. So let's revise again what we call to that process. Now you know that solid is directly converted into liquid. Ice can easily change into the liquid water, right? So what we call to that process? Yes, give stress to your mind. What we call to that process? Fusion. Yes, we call to that process as a fusion. Now liquid, water, change into gas. What we call to that process? Yes, we call to that vaporization. Vaporization. Now gas, when the gas changes into the solid, what we call to that? Deposition. We called it to as deposition. In older book, sublimation is written, and if you have an old book, then change it and learn it as a deposition, not sublimation. What is sublimation? Sublimation when solid directly convert into gas without going into liquid state. That process is called sublimation. That process is called sublimation. And do you know the few examples of sublimation? Examples of sublimation. What are the examples of sublimation? Yes, give stress to your mind. There are 4 examples. What are the 4 one? First one is ammonium chloride. Ammonium chloride. Second example, camphor. In Hindi, which we called it as kapoor. Third, naphthalene balls. Naphthalene balls. And dry ice. Do you know what is dry ice? Dry ice is solid carbon dioxide. We called it dry ice to solid carbon dioxide. And these are the examples of sublimation. Okay, so when solid directly changes into gas, that process is called sublimation. And if gas is changing into the liquid, what we call to that process? When gas is changes into the liquid, as you know that water vapors goes upward and they will change into the cloud. By which process? Yes, condensation. That process is called condensation. Condensation. That process is called condensation. Now when liquid change into the solid, that process is called solidification. That process is called solidification. Okay, so as you know that the gases can liquefy, है ना? So what are the necessary conditions to which we can liquefy the atmospheric gases? So what are the methods to liquefy the atmospheric gases? 1. By applying pressure. Applying pressure. And what is the second method? By reducing temperature. If we apply the pressure and we reduce the temperature, then our gases can be liquefied. As you know that carbon dioxide cylinder, oxygen cylinder, where we fill the gases but in the liquefied form. And how we can liquefy the gases? By the applying pressure and reducing temperature. Friends, now what we call to the process when solid convert into liquid? Yes, fusion. And do you know the definition of latent heat of fusion? Latent heat of fusion. Latent means the heat change, the small change, the energy required to change. Latent. Heat, energy. The heat means energy required to change. Now what is the meaning of fusion? Solid convert into liquid. So basically, now what is latent heat of fusion? The amount of heat energy required to change 1 kilogram of solid into liquid. And you know that when solid is convert into liquid, that temperature is called melting point. So what is the amount of energy required to change 1 kilogram of solid into liquid at its melting point? Now, you know vaporization. What is vaporization? When liquid convert into gas. And at what temperature? Yes, at its boiling point. So, what is latent heat of vaporization? The heat energy required to change 1 kilogram liquid into gas at its boiling point. Okay, so now read. The heat energy required to change 1 kilogram of liquid to gas at its boiling point. That is called latent heat of vaporization. So friends, do you know the evaporation? What is evaporation? Evaporation, the change of liquid into vapors at any temperature. At any temperature means at room temperature, but below its boiling point. That is called evaporation. And if it occurs at a boiling point, if liquid change into vapor at its boiling point, then what we called it as? We called it as boiling. Then we called it as boiling. When it occurs at its boiling point. Now, what are the factors which affect the evaporation? Perhaps you know, you remember, but still if you don't remember, there are 4 factors. What are these 4 factors? One is surface area. Second is temperature. Third one is wind speed. And fourth one is humidity. Now, if we increase the surface area means, as you can see, the area, I kept the water in a tub and I kept the water in a bucket. So, which has more surface area? Yes, tub has more surface area. So, the rate of evaporation is also more in the tub as compared to the bucket. Similarly, if we increase the temperature, then again the rate of evaporation also increases. As you see, in the hot summer day, the rate of evaporation is more as compared to the rainy day. It means if temperature is more, rate of evaporation is more. Increase in wind speed increases the rate of evaporation. If there is a heavy wind, then again the rate of evaporation is more. Now, the fourth one is humidity. Now here, increase in humidity decrease the rate of evaporation. It decreases the rate of evaporation. What's the meaning of humidity? Humidity means the moisture present in our atmosphere. That we called it as humidity. If in our atmosphere already the water droplets are present, then what is the effect in the rate of evaporation? It will decreases because already water is already present in our atmosphere. So basically now out of the 4, if you conclude, the 3 increases with increasing the evaporation. But humidity increases, then the rate of evaporation is decreases. Getting? And students, do you remember the difference between evaporation and boiling also? What is the difference between evaporation and boiling? Evaporation is the surface phenomena, where boiling is a bulk phenomena.